Okay, so let's look at example 2. Example 2, we now have a student randomly guessing on an exam with multiple choice. Not recommended, by the way. But now another person's randomly guessing on an exam with 7 multiple choice questions, each with 5 choices for the correct answer. Find the probability that the student guesses correctly on no more than 2 questions. First off, how do I know it's binomial?
It's yes or no, right or wrong.
It's either right or wrong, right?
Two.
And every time you guess, you have the same chances of getting it right. Because you're guessing out of 5 bubbles every time. We see that? That's what makes it binomial. So let's just talk about this. In this case, what is n?
Number of answers, so 5.
The 5 has to do with each individual question. But how many total questions does he have? That's your n. So he's going to guess 7 times, so that's like your number of trials.
Okay.
Where does that 5 come in, though?
The probability,
It comes in with the probability. The probability of guessing correctly
1
is 1 out of those 5 bubbles, right? There's A through E, and only 1 out of those 5 is correct, so that's where the 5 comes in. The 7 has to do with he or she, we don't know if it's a he or she, is guessing 7 different times. And the P, the probability of guessing correctly on any one time, is 1 out of 5 bubbles is right. We don't need Q right now, but we will in a few minutes, so tell me how to get Q.
4 or 5?
4 out of 5, why?
The complement of P.
It's the complement. If there's one way to get the problem right, there are 4 ways to get it wrong. Or you could subtract that from 1, and you'd get 4 out of 5. We don't need Q at the moment, but we will in a few minutes. And what is this question asking us to find?
Probability that the student guesses correctly on 2.
Does it say 2 or more? Careful.
No more.
No more than 2. No more than 2, correct. What does that mean? No more than 2.
I think the most I can get is 2.
The most you can get is 2,
You can get 1 or you can get 0.
or you get 1 or 0, so we're really saying 2 or less. Another way of saying that, right? 2 or less, correct?
Yeah.
Sometimes you have to reword it in your own words. And then if we write it as symbols, do we agree that it's less than or equal to 2? So what am I going to do to answer that question?
See ya.
Binomial CDF, because I need everything from 2 down. Now what goes into my CDF? The 7, because that's my N. The 1/5, because that's my P.
And then 2.
And then the
1,
2.
0.
I'm sorry, say that again.
Oh, do you just do
I don't have to do the 2, the 1, and the 0, because remember, our options are to do the PDF a bunch of times,
or the CD?
or just do the CDF, and the CDF automatically does 2 and 1 and 0. It does everything from that number down to 0. What are we getting?
.85.
0.85, 1?
No, 0.852.
852? Yeah? So there's about an 85% chance that the student's going to get 2 or less of them correct. A pretty high probability of an F. We recommend not guessing on exam. It's not the most efficient method. We all right there? Example 3, we now have that 45% of all blood donors have type O blood. And we're selecting 5 donors randomly. And the first part says create a table to illustrate this probability distribution. We'll talk about that in a minute. The next part says find the probability that at least one donor is type O. I think we can make already answered that last question before we even know what I'm talking about with that table. What does that problem make you think of when you read the question at the very bottom?
The complement of none.
Aha! She says it's at least one, which makes her think about the complement of at least one, which is always none. How many times have we talked about that one already, right? So I'm doing the problem at the very bottom first. At least one type O we agree with Evelyn that the complement is that none are type O? And so every time we see an at least one problem, what do we do? What do we do with that complement though? 1 minus, yeah? 1 minus the probability that none are type O? Every time we see an at least one question, that's what we've been doing? Even before we learned binomial? So we didn't have to know binomial to do this problem. We could have. I'll show you there in a second how we did it. So if I have 5 people and none of them are type O, what am I going to do? I'm going to find the probability that none of them are type O. I have 5 people. My hint for groups of people or things. Look at them. So a review question. It goes all the way back to 4.2 or 3. It's a ways back. So you're flipping through your notes. So my hint is, whenever you have groups of people or things, look at them one at a time. If I have 5 people and none of them are type O, tell me about the first person. They're not type O. And, oh, did you hear that? And tell me about the second person.
They're not type O.
Not type O. And, what'd you say? And then I end up multiplying each of those individual probabilities. So my hint back in chapter 4 was anytime you have a group of people or things, look at them one at a time and you can multiply those probabilities. I can't remember if it was 4.2 or 4.3. I think it was 4.3.
4-3, is that
4-3?
multiplication rule?
Yeah, the multiplication and the complements together.
Yeah.
So not type O and not type O and so forth. All 5 of them are not type O. Remember that now? Okay, and when it's an and, we do what? Multiply the probabilities. Well, what is the probability that one person is not type O?
55%.
55%, he says. Where do you get that?
So,
Because 45% is the probability that you are type O, right? If 45% are type O, that's a probability equal to 0.45, right? We're talking about not type O, so what do? How'd we get to 0.55? Subtract it from 1. If you think about percents, you would have come up with the 55%. So if there's a 0.45 probability that you are type O, there's a 0.55 that you're not type O. So what's the probability the first person is not type O?
0.55.
0.55. And the probability the next person's not type O? 0.55. And the next one? 0.55. And the fourth one,
0.54.
and, I heard that. And the fifth one, try to change the numbers on me. Well, review question. There are problems on the exam very similar to this where you could use a binomial to answer it, or you could use the old rules about at least one and the multiplication rule to answer it. I'm doing the old ones to jog our memories. A shorthand way to write this is 0.55 to the fifth. .95? What comes after the 5?
Like a 9 and then 6.
9596?
No, I
Oh, I
rounded
got
it.
it.
It was like 9.
Does it go to 950 then?
No.
I just want to know what the third digit is if I round.
That's after you subtract.
0.55 to the fifth is-
Right, after we subtract,
Yeah,
what's the answer to 3 decimal places? That's my question.
yeah. it'd be
Or maybe you
0.95
round
if you're-
It is a 0, I just want to, we round it to 0? I just want to
Yeah.
make sure. I didn't know if we were leaving it off or rounding. Okay with that? So, what did we just find right here? That none are typo? None are typo, this part right here. That's what this part is, right? Nobody's typo. How many people is that? That are typo if it's none? Trick question. None means how many are typo? 0. We're really talking about none are typo. It's the same as saying 0 are typo. Excuse me. 0, they're giving me an X. Aren't they giving me an X if they're saying 0 or typo? So what's another way to find this using binomial? If I want the probability that 0 of them are type O,
Did you use,
PDF.
I'd use PDF, because I'm talking about a specific point. Binomial PDF. And what would I put in there? An N comes first, so what's N in this case?
5.
5. What's the P? Is it 5-5 or 4-5? It's the 4-5, because we're talking about typo, being how many of them are being typo. 0.45, oops, lost my point there. So this is how many people, this is the event we're looking for, typo. And how many do we want? 0. Type this into your calculator. I'm squeezing in this corner here, sorry. It should be the same as what I have in my red box down here, which I haven't simplified. We should probably write that out. Should be like 050, something like that. What's 0.55 to the fifth? Same thing. So this is using the multiplication rule, that's recognizing it was binomial. Either way, we have to take 1 minus that, and we're going to get the same answer either way for this problem. I can't stress that enough, is that our binomial is just a special case of the multiplication rule. So there's times on the test where you might use binomial, you might use multiplication. I don't care which way you do it, it'll work. Put your hand. Yes.
So how would we think of this problem as being binomial?
So every person is either type O or not. So those are your 2 options. Are you type O? It's a yes or no question. Right? So if I come up there, are you type O? You're going to say yes or you're going to say no. So those are
So
your...
we wouldn't think of like how there's more types than just O or not?
You could. There's a lot more types than O. But since this question is just asking about the probability of being type O, that makes it a yes or no question. Because all the other ways, all the other types of blood get lumped into not O. There's basically O and not O. It's kind of like if I asked you your favorite flavor of ice cream. And I want to know the probability of some certain number of people saying chocolate. There's a lot of other flavors, but basically it's either chocolate or not chocolate. So that's what makes this one binomial. So you're right, sometimes there's more than 2 outcomes, but the way the question's phrased makes it only 2, makes it a yes or no. Okay, so let's go back to the part where it asked about the table. When it asked about the table, the problem is what there? Do we know N and P? For this problem, example 3, we know N and P, but the table doesn't give us anything about an X at all. Right? Doesn't give us anything about an X. So here's what the table does. I'm sorry, say that again?
Isn't X 5?
That would be if the question, so his question was, isn't x equal to 5? X would equal 5 if I said, what's the probability that all 5 of them are type O? I'd be giving you a
X
number.
N.
Yeah,
N.
N,
5
yeah.
of them.
N is the 5, but X could be, then 0 of them are type O, or 3 of them are type O, but there's no question here, so there is no X. So let's talk about all the possible X's we could have with this problem. So we're creating a table, X and P of X. Out of 5 people, how many of them might be type O? Could be none of them. Well, we already found that probability. We just found that, right? It could be one of them is type O. It could be that 2 of them are type O. It could be 3 or 4 or 5. Those are all the possible answers if I had a group of 5 people. Remember making those distributions last week, early on? So we could do binomial PDF all these different times to get these answers. Binomial PDF with x equals 1. Binomial PDF with x equals 2. Binomial PDF with x equals 3 to fill in this table. We agree what I'm talking about there? That's how we get all these. But there's a shortcut. The shortcut is to do binomial PDF, tell it your n, tell it your p, and don't bother telling it an x value. Leave off the x. Leave it blank on your screen if you have the screen that asks for x. Just don't put it in there at all if you have the older calculator. And you should get a list of numbers that you can scroll across. And this should be the first one. You get a list of numbers and you can use your arrow button to look at them all. I want to see if we get to that screen first, and then we'll start copying down those numbers.
And then just leave the X value empty.
Leave the x value empty. So those numbers are all of these probabilities in order. So the very first number has a whole bunch of digits. What's it say? 0.05, what's it?
0.3284.
Yeah, it just keeps going and going and going, but we're just going to round it to 3 decimal places. And what's the next one? 0.26?
No, 206.
206, thank you. 0.206, what's the next one? 337, I'm assuming you guys are rounding,
Yeah.
yes?
Yes.
Next one? 276?
113.
113,
0.18.
018. So this is like those probability distributions that I gave you in 5.1, where I said, here's the table, what's the probability of exactly 4? If I ask the probability of exactly 4,
0.113.
it'd be 0.113, it's right there in front of you, right? And if I said, what's the probability of exactly 2? You'd say, oh, it's 0.337. So this gives you all the probabilities, so you can just look at them easily and answer any questions. Let's go back and look at this question now. At least one of them is type O. At least one means 1 or more. At least one is 1 or more, right?
Yeah.
1 or more is everybody below this red line. Do we agree that all of these, 1 or 2 or 3, that's at least 1? If it could be 1 or 2 or 3 or 4 or 5, guess what all of these add up to? All of them just in the red box. Take the 0.05 out, he says. They add up to 0.95. That's what we found. If you want to, for fun, add all these up. They should add up to 0.950. They might be off because we rounded, but it should be pretty close. Or, I like the way Kevin looked at it. He goes, why not just take this one off? Just take that one off, right? Take it off from 1, because this is the red box down below is the complement of what's up here. So 1 minus this guy is everything down below. So there's 3 different ways to do this one problem. You could look at it as a multiplication thing. You could make a table and just count the ones you want. You could look at it as binomial and use your binomial PDF or CDF. Questions? Yes.
For the binomial PDF, I see how we got 5.45, but then for the x value where it says 0, I'm a little confused how we got.
Why we did that over here?
Yeah.
Because for this particular one, we were worried about none are typo.
Oh, okay.
And if it's none,
Sure.
that's the same as saying 0.
Got it.
Other questions?